I've been trying to add lighting to my game for a long time, and I finally figured out how to do it. So I decided to share how I finally figured it out, because even AI couldn't help me with this one. I went for the most basic lighting I could think of, which was that I would make the whole world darker except for the spots where I want there to be light. This made more sense to me than somehow trying to brighten up lit up areas using some kind of additive white light, but this led me to a problem. It's easy to draw a texture to the screen, but how do you not draw a texture? As in, draw everything except that texture. From my basic knowledge of photocompositing, I knew that what I was looking for was called a mask. The basic idea would be to start with a darkness texture, then I would cut out sections using a mask. This would leave me with the full lighting texture, which I would then draw as an overlay to the screen. Now to actually implement the masking, which was the hard part. I could use a shader. They can pretty much do everything you want as they can manually control every pixel individually, but I found a simpler solution, which is OpenGL blend modes. These were the bane of my existence for a while, as they made absolutely no sense when you first read into it, so the reason I wanted to make this video is to explain them here. Before we can understand the blend modes, we need to understand the two images we're working with, the source image and the destination image, also known as the frame buffer. OpenGL basically works like this. Whenever you draw something, OpenGL calls it the source image for a while. So then, when you draw another thing, that thing becomes the source image. Whatever else has already been drawn in this frame is now renamed to the destination image. As we continue to draw, we can see how the destination image is really just a buffer of what has been drawn so far, also known as the frame buffer. So, to simulate already having a frame buffer, let's draw this Mario background with normal blending functions. Whatever the colors are in the background, we'll simply draw them to the final color. No blending is going on yet. Now, we'll draw Mario, but let's enable blending first. So now, we've successfully made Mario our source image, and the background, also known as whatever has been drawn in the past, is the destination image. Now let's make sure to call GL-enable GL-blend to enable blending. The way Mario will actually be drawn with blending is determined by these equations. Here R, G, and B are the final colors. Our source, G source, and B source are the source image's colors, and similarly for dest, those are the destination image's colors. And then what is this A and B? A and B are of the user's choosing. They can be either 0, 1, A subsource, or 1 minus A subsource. And there are some other options, but they don't seem that common. You can set the values of A and B via the function glBlendFunc. So let's run through an example. Let's arbitrarily set A to 0 and B to 1. Then the equations cancel out such that the final image is going to be the exact same as the destination image. So, if you use this blend mode before your call, you'll draw nothing except the background. Let's try A equals 1 and B equals 0. This would mean that only the source image gets drawn. Note that the background is still being drawn. This is because we've already drawn the background as normal earlier and entered it into the frame buffer. Then we set Mario to be our source image, which means that Mario is the only image we care about drawing at the moment, and thus only the region of Mario's image gets affected. We can see that as expected, only Mario's colors are getting drawn in this region. Let's try A equals 1 and B equals 1. The final color is a result of adding together the source and the destination colors. If the value is greater than the max value of 1, it simply gets clamped. Unless you're trying to use HDR, but that's beside the point and outside the scope of the video. Let's try A equals 1 and B equals A sub source. The equation becomes R equals R sub source plus R plus dest times A sub source. So we're getting all the color from the source Mario image, and we're also adding on some color from the destination background image. But it's scaled depending on how much Mario's source alpha is at that pixel. So if Mario's source alpha is 0 at a spot, which means transparent, then we're not going to draw the background there at all. However, whereas alpha is 1, which is everywhere that Mario is opaque, we're going to add on the colors of the background destination image. If our goal is to draw Mario normally as he would appear in Super Mario Bros., this is the opposite of what we want. We actually want to draw the background where the alpha is 0, and we want to draw none of the background where the alpha of Mario is 1. Okay, now that we've done that, we can understand our hole punching lighting example. Let's draw the background in Mario first so that we can draw our lighting over it. Now let's add darkness to the whole screen with GL Clear. What we want is for just darkness to be our destination image so that we can cut holes into it using this lighting texture. I mean, imagine if everything was the destination image. We would cut out a section from the entire screen. Actually, that could make a cool possibility. This is where we run into a bit of a problem though. Once we've drawn the background in Mario, there's no way in OpenGL to simply restart the frame buffer and just have the darkness texture, since the frame buffer is the contents of the screen. To fix this, we must create a new frame buffer object. We'll use this frame buffer to draw the darkness and hole punch in the lighting, and then we'll draw this frame buffer's image to the main frame buffer. But wait, that leads to another problem. Before I was rendering everything to the same frame buffer, which is the screen. This means that OpenGL could take everything I was about to draw in a frame, combine it all, and always draw to the same source every time. But now I don't always want to draw to the screen anymore. When I'm cutting out from the darkness texture, I only want to draw to that texture. So now this means that OpenGL has to keep changing the source it's drawing to twice per frame. First set the source to the darkness texture, then to the rest of the world, then next frame back to the darkness texture, and so on. And this is unavoidable because the darkness texture will change every frame whenever a light source moves. But I knew that this was something which was inevitably going to happen, especially if I wanted to do cool stuff with shaders later, like adding bloom. So I had to concede that this game would probably never run on your old Chromebook you have somewhere in your parents' house that you won from a coding competition in 2013. But I know that I have to get better at conceding things like this if I'm ever going to finish the game. Okay, so this is what we're going to do. First, we'll set up the lighting frame buffer object, FBO. To do this, we'll draw the darkness, and then we'll draw the light texture with some special A and B which we'll decide later. Draw the light texture with blending. Then we'll draw the background, Mario, and this lighting frame buffer with regular blending. Now, which A and B do we want? Let's focus on the alpha value since that's most important. What we want is to have A sub dest, except for where A sub source is greater than 0. To achieve this, we can set A to 0 and B to 1 minus source alpha. This gives us A equals A sub dest minus A sub dest times A sub source. So, we have A sub dest, except that we subtract off a factor of A sub dest multiplied by the alpha of A sub source. And A sub source goes from 0 to 1. So we're cutting off a bit of A sub dest depending on what A sub source is. And that gives us what we wanted. Like and subscribe if you found this tutorial helpful, and like and subscribe to help support the development of my game Earthmage Icon.